Bismillahirrahmanirrahim. Welcome students. As you all know, we completed chapter 1. In previous lecture, I asked you all if there was any difficulty in the topics that we have done previously. Some of your friends did text me and they said they were having a problem in zero error. So I decided to go through the topic again. Today's topic, concept of zero error. Today we will only discuss zero error, develop the concept, and know how to identify it in case of vernier caliper and screw gauge. After identifying it, we should know how to calculate it and then to apply correction to the final reading. So let's see the number line. In previous classes, you might have drawn number line. On a number line, the 0 is in the middle of all the positive and negative integers. Positive integers towards the right side with positive sign. You don't need to add a positive sign. It's understood that these are positive integers. And negative integers to the left side with negative sign. All the numbers towards the right are greater than 0. All the numbers towards the left are in decreasing pattern. So this concept you can easily apply on vernier caliper and can find the zero error. What is zero error? As discussed previously, it is a condition in which instrument registers a reading when there should not be any reading on the device. If you see the picture, weighing scale, it is showing a reading 2 kilogram when nobody is standing on it. It means this instrument has zero error in it. What should have happened? If this instrument, this weighing machine was perfect, the reading should have been 0. But since there is a reading, it means there is an error. So when does the instrument does not have a zero error? There are two pictures in front of you. Picture on the left is of a vernier caliper, and on the right is a screw gauge. Whenever you go to physics lab and vernier caliper and screw gauge are handed to you, the first observation that you take is zero error. On the right hand side, if you observe closely, the 0 of vernier scale perfectly coincides with the 0 of main scale. It means that your instrument has no zero error and hence no zero correction is required. In this picture, the index line or datum line coincides with the 0 of circular scale. This means that the instrument has no zero error in it. You have to keep in mind that zero error is observed before the start of experiment. That is, when the object is not placed between the jaws in case of vernier caliper and not placed between stud and spindle in case of screw gauge. So the initial readings when vernier caliper and screw gauge are handed over to you is you have to take the least count and you have to find the zero error. How to identify and calculate error in case of vernier caliper? Coming back to the number line and see the picture. You have to note the zero error when no object is placed between the jaws. It means the vernier caliper was handed to you and you saw that the 0 vernier scale was slightly coming towards the right of the main scale. Now see the number line all the positive numbers, all the positive integers are towards the right of the 0. So this error you can relate with all the positive integers is positive error. Then you have to do the calculations. 0 error is equal to Vernier scale into least count. Vernier scale division is the best coinciding line which matches with the division on the main scale. How can you find that division? If you move your eye from left to right while observing the Vernier scale, it is the first division that is to be taken into consideration. In this picture, if you closely observe, 0 does not match perfectly with the 0 of main scale. If you see 1, the 1 division of Vernier scale matches with the division on main scale. So you will take 1, you will multiply it with the least count of Vernier caliper, which is 0.1 millimeter. The answer is going to be 0.1 millimeter. And you can convert that millimeter into centimeter by dividing the value by 10. So your answer is going to be 0.01 centimeter. Since this is a positive error, you can write a positive sign with it. But the correction applied will be negative because this is an additional value. It didn't stop here, the Vernier 0. Suppose this 0 is the finishing line and this 0 doesn't stop here, it is going ahead, it is moving ahead. So this is an extra reading. You're going to subtract it from the final reading. You're going to add a minus sign to it. You will apply this correction when the final readings are taken. Please keep in mind that when you are going to take the Vernier scale divisions, there is a possibility that more than one line can match. But the first division that best matches with the main scale division is to be taken into consideration. In this picture, if you closely observe, the 0 of Vernier scale is slightly towards the left of main scale. And you observe the number line, all the negative integers are coming towards the left of the 0 on a number line. So this 0 is towards the left, all the negative integers are towards the left. So this error is a negative 0 error. Calculations. 0 error is equal to Vernier scale into least count. But over here, to find the Vernier scale reading, it is different from the one we did previously in case of positive error. Over here, you subtract the best coinciding line with the total number of divisions on Vernier scale. So the total number of divisions on Vernier scale are 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These total number of divisions 10, you are going to subtract 10 by the best coinciding line. Over here, you see 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 is the best coinciding line. So 10 minus 8 is equal to 2. You will multiply it with the least count. 0.2 millimeter will be the answer. And since it's the negative error, you will add a minus sign. Now this Vernier 0 wouldn't reach the 0 of main scale. It was behind. It was lagging behind the main scale, few points. So how are you going to cover up those points? You are going to add this value to the final reading. So in 0 correction column, you are going to write this value 0.02 with a positive sign so that in the end, after taking the final readings, you can add this value to the final reading to get accurate results. However, in case of screw gauge, You can't apply that concept of number line. In case of screw gauge, if the zero of circular scale is below the index line, this is your index line. Index line is also called as the datum line. This index line, if the zero of circular scale, this is your circular scale, is below the index line, such an error is positive zero error. Formula for it, zero error is equal to circular scale reading into least count. You will count the number of divisions. The line that is matching with the index line. Over here, it's a bit simpler. You don't need to look at each and every reading. Just the line that is matching with the index line is your circular scale reading. So it's 0, 1, 2, 0, 1, 2, and 3. So third line. So 3 multiplied by the least count, 0.01 millimeter. You can convert millimeter into centimeter by dividing the value by 10. Answer is going to be 0.003 centimeter. This is a positive error. You don't need to add a positive sign. If you want to, you can. But the correction is going to be negative, minus 0.003 centimeter. And you will apply this correction after taking the final reading. In case of this situation, in this picture, if you see the zero of circular scale is above the index line, you will have to count the number of division. The starting line and the finishing line are the same. Obviously, if you see over here 95, then 96, 97, 98, 99, 100. So it's 0 and 100. You can't write 100 or 0, two numbers over here. So the starting line and the finishing line are the same. Basically, it couldn't complete its rotation. It's 2 points short, the circular scale. So it's 2 divisions short. So you're not going to say it's 96, 97. It's not going to say 98. You're going to subtract it. It's like 100 minus 98 would be 2, or you can count the number of divisions that couldn't quite reach it. So it's 1, 2, 2 lines. 2 multiplied by least count, 0.01. So it's 0.02 millimeter. Since this is the negative error, you will use a negative sign, and the correction applied will be positive. We are going to add this value to the final reading. Summary of today's lecture. Number line, I did discuss with you that by using number line, you can easily identify the errors in vernier caliper. In the first picture over here, if you see the zero of vernier scale is coming towards the left, all the negative integers come towards the left of the number line. This is a negative error. How can you find it? You are going to find the best coinciding line, and you're going to subtract it from the total number of divisions. So the best coinciding line is 0, 1, 2, 3, 4. It's 4. So 10 minus 4 is 6. 6 multiplied by the least count, 0.1 millimeter or 0.01 centimeter. You're going to multiply it. This is the negative error. You will use a negative sign, so it's going to be minus 0.06 centimeter. And this is lagging behind. The vernier scale 0 is not quite there to the 0 of main scale. It's lagging behind. So how is this distance going to cover up? Obviously, at this value, this length, you will add it to the final reading. So this is a negative error, and the correction would be that you will add the value of 0.06 centimeter to the final reading. In second picture, if you see the 0 of vernier scale is coming towards the right, and if you see the number line, all the positive integers are coming, always come towards the right. So this is a positive error, and you will find the best coinciding line, multiply it with the least count. Over here it's 5 multiplied by 0.01 centimeter. The answer is going to be 0.05 centimeter. This is a positive error, and the value gets subtracted from the final reading. Let's see the picture of screw gauge. In the first picture, the 0 of circular scale is below the index line. Take this value, 1, 2. So over here in screw gauge, again, it's very easy to find the circular scale reading. 2 multiplied by the least count, 0.01 millimeter. And this is the positive error, you are going to subtract the value of 0.02 millimeter to the final reading. And in the second picture, 95, 96. 96 is the value, but you're not going to say 96. How many divisions was it short to join with the index line? It was 1, 2, 3, 4. 4 divisions short in joining the index line. So you're going to say 4 multiplied by the least count of screw gauge, which is 0.01 millimeter. Answer is going to be 0.04 millimeter with a negative sign. This is a negative error, but the correction is going to be positive. We are going to add the value of 0.04 millimeter to the final reading. That was it for today, girls. Home assignment is you have to complete your work. All exercises should be done in your copy. You have a test on Monday. Article 1.6. 1.6 includes all the measuring instruments, that is length, mass, time, and volume. 1.7 includes significant figures and rounding of data. Please prepare well for the test. I hope you all score good in the test. Still, if you have any queries regarding the lecture or any other topics that we have done previously, you can contact me and then we can do another class on that topic. Take care. See you in next lecture. Allah Hafiz.